All right, chapter 20 is about carbohydrates. They are known as sugars and starches. They're what's called a polyhydroxyaldehyde or ketones, or compounds that could be hydrolyzed into them. All right. If you look at kind of the general structure, you can see that every carbon, all right, has basically a water on it, or you can look at it as an alcohol or water. There's H2O. So there's HHO, HHO, water, water. Okay. And then at the two ends, you usually have an alcohol on one end and an aldehyde, if you have an aldehyde sugar, or you have a CH2OH, CH2OH with a ketone. Okay, so either the first carbon's either an aldehyde or the second carbon's a ketone. But then you have alcohols on every other carbon on the molecule, hence the polyhydroxy part. Okay, the simplest carbohydrate is what's called a monosaccharide, meaning just one sugar, like this is glucose. All right, and this is just fructose. If you combine the two, then you have what's called a disaccharide, and you have sucrose. But a monosaccharide is just one of these sugars, and there's lots of different ones. This book only talks about more of the common ones. Okay, so like I said, here's an example of a disaccharide where you have two. All right, these are two lactose molecules combined, and that's basic. Or I'm sorry, this is the structure of lactose, and this is an acetal bond. Remember we talked about acetals in one of the chapters, in the aldehyde chapter. So remember, and we're going to be seeing this quite a bit, the acetal. Remember, the acetal is a carbon. So remember, right here you have a carbon, and you have two oxygens attached to the same carbon. So you have a carbon, oxygen, carbon, oxygen, and then you have your bonds outside of that. All right, that carbon is the acetal carbon. And this particular carbon is going to become important because we have two types of sugars. We have what's called an alpha sugar and a beta sugar. And it all depends on where this oxygen is. If it's going up or if it's going down determines if it's an alpha or a beta. And they have different properties, all right, which we'll talk about in this chapter. All right, a polysaccharide is where you have several sugars, more than two. Now you could have something called a trisaccharide, a tetrasaccharide. Those obviously have three or four sugars, but usually if you have three or more sugars, they just call it a polysaccharide, meaning many. All right, so starch is an example of starch. Glycogen is an example of this. So we'll talk about those as well. All right, the way carbohydrates are synthesized is by photosynthesis. All right, our sugar comes from plants, and the way plants are made is the opposite of us. They absorb carbon dioxide and water to make sugars and oxygen. All right, and then we use the sugar and we burn the sugar. All right, monosaccharides can range somewhere between 3 to 6 carbons. All right, and can either be an aldehyde or a ketone. All right, and every carbon other than the aldehyde and ketone carbon is going to have an OH group. All right, so if it's an aldehyde, it's what's called an aldose. All right, if it's a ketone, it's called a ketose. So keep that in mind when we start looking at some of the names. All right, the simplest aldose or aldehyde sugar is called glyceraldehyde. This is the structure of glyceraldehyde. You can see that you have a carbon with an OH, a carbon with an OH, and the first carbon is an aldehyde. All right. Dihydroxyacetone is the simplest ketose or three-membered sugar, where you have an OH and OH on the 1 and the 3 carbon, and then a carbonyl on the second carbon. These are constitutional isomers. Remember, constitutional isomer means same formula, but the structures are a little different. All right. A monosaccharide can, again, we talked about this, can have somewhere between 3 to 6 carbons, and they either call them a triose, tetraose, pentaose, hexose. A pentose and hexose are the most common one, such as fructose and glucose. All right. You can also combine the functional group, either aldehyde or ketone, with the triose. So glyceraldehyde is an example of an aldotriose. Aldo meaning aldehyde, triose meaning 3 carbons. Or a ketotriose, which is like this compound, or dihydroxyacetone. Ketotriose, keto for a ketone, and triose because there are 3 carbons on it. All right, so just some nomenclature. Monosaccharides are sweet. They are very polar, because they have lots of hydrogen bonding, they have relatively high melting points. The presence of all these polar groups make them very soluble in water, right? They also have chiral centers. So now we get a little bit back to chirality, stereochemistry that we talked about in one of the chapters. The carbons that have the OHs on it, other than the two carbons at the ends, are chiral, right? Because you have four different groups attached to the central carbon. All right, so an aldehyde, which is the simplest of all the aldoses, has a chiral center, so there are two enantiomers. There's what's called D-glyceraldehyde and L-glyceraldehyde. The way that you know if it's D or L is where the very last OH group is on the backbone, which we'll see a better example. This is kind of a bad example, but the OH is on the right side, so we call that the D-glyceraldehyde. If the OH is on the left side, we call it the L-aldehyde. I'm sorry, the L sugar. All right, this is exactly what the slide says. The D is for the right side and the L is for the left side. So do you remember Fischer projections where you kind of cross the T and this is kind of what it resembles? The H and the OH mean are coming out towards you, and the two on the axes are going back into the plane. And kind of drawing them in a Fischer is a much easier way to draw them. So glucose, you can see, has four chiral centers on it. All right, see four of them because it's a carbon with four different groups. This is an aldehyde group, this is an alcohol group, this is a hydrogen group, and this is another carbon with an alcohol on it. So these are four different groups on this carbon. And then this carbon has four different groups, and this one, and so forth and so on. All right, so what you do is you look at the bottom alcohol, OH, and determine which side is the OH on. If it's on the right side, this is considered a D glucose. This is on the right side, this is D. Okay. So, all right, I don't really see the difference here. I think they're just trying to show you what the Fischer projection looks like. So glucose, and pretty much the constitutional isomers of all sugars are just the different placement of where the OH are, especially if we're talking about an aldose in this case. Okay, in particular, an aldohexose, aldehyde, hexose, 6 carbons. And basically, it's a different place of all the OHs. You can have all the OHs on one side, that's one sugar. You can have this, which is glucose. You can have the OH here and the other OH here, and so forth and so on. You can have so many different possibilities, and those are all different sugars. Either galactose or glucose or any of the oses. Okay, so here is where it says it specifically. It's the very last OH which determines the D and L. So in this case, we have the D sugars. All right, so here is a D glucose where the OH is on the right, and here's L. And specifically, you're just looking at this very last one that's close to the OH group, the CH2OH. So these are enantiomers of each other. All right, the D glucose is the naturally occurring, and the L one is the unnatural. So nothing makes the L glucose. Our bodies can't even do anything with that L glucose. All right, glucose or dextrose is also another name actually for glucose, is blood sugar and is the most abundant monosaccharide. That's what our body uses. All right, we don't have to get into the medicine of it. Excess glucose is stored as a polysaccharide, as glycogen, or as fat. We've talked about this. Insulin regulates blood glucose. It's basically the one that uptakes our glucose into our cells. Patients with diabetes, have insufficient insulin or a very large amount of glucose. We have to go over that again. All right, so here are some common monosaccharides: glucose, galactose, and fructose. All right, so glucose. So notice the difference between fructose and galactose. The only difference is this OH group right here. Okay, notice this OH is on the right, this is on the right. This OH is on the left, this is on the left. This is on the right, but this is on the left. This is on the right, and this is on the right. So just by switching one of the OHs, you actually have a different sugar. All right, fructose, notice, is very similar to glucose, but you have a ketone at the 2 position rather than having aldehydes like what we have here and here. So notice we still have an OH on the right, the left, and then 2 on the right. OH on the left and 2 on the right. So fructose is very similar to the structure of glucose with the exception of these 2 parts to it. That is the only difference. All right, galactose is a common component in lactose. Fructose is a common component in sucrose. It is a ketohexose found in honey and almost twice as sweet as table sugar with the same number of calories per gram. So honey is compared of a ketohexose. It's not quite sucrose. There's a bunch of stuff in it, and it's very interesting. It's twice as sweet, but about the same number of calories. So you can technically use half the amount of honey. That's why they say honey is much better for you than just having sugar. The reason is because you can use half the amount for twice the amount of sugar, so you don't have the huge amount, and it's the same amount of calories. So half the amount of sugar, half the amount of calories, but you have the same amount of sweetness. Okay, we're going to stop it right there, and when we come back, we will pick it up at 20.3.